Welcome to probability video 8.1, Venn diagrams and the number of elements in overlapping sets. So let's start off with these four drawings of overlapping sets. Just to let you know, the U stands for the universe. The universe could be whatever it is you're talking about. The number of students in a classroom, the number of people on the planet, the set of all integers, anything like that. All right, so over here, I've got union, A union B. That union means the word or. So I could be in set A or I could be in set B. So that shading would look like that. Over here I've got intersection. For the intersection I think of the word and. And a way for me to remember is that kind of reminds me of letter A for and. So I've got to be in set A and set B at the same time. So it's going to be that region there, and I call that a football. Just helps me remember the formulas later if I have concrete terms. Difference. Over here, this is going to be things that are in B but not A. So B but not A. So it's going to be this, kind of like part of a moon. Over here, the complement. Okay, this is read as A prime. And it really means not A. So the entire universe, but not being an A. So I'll just put a little force field around set A, and that'll be everything else. All right, those are four of the more common situations. Now let's make a note. The addition rule that we've been using before only applies to mutually disjoint sets. That's sets with no overlap. So in previous problems we've had the total and we've divided it up into either A, B, C, etc. Notice there's no overlap. And in those cases we could say this plus this equals the total. However, if there is overlap, we've got to use some different techniques. So here's two of the more common ones we'll be using. Two overlapping sets, as shown here, or three overlapping sets, as shown here. For the three overlapping sets, you want to make sure you draw the circles so you get all those regions. Okay, for two overlapping sets, the number of elements in A or B is the number in A plus the number in B minus the number in A and B. And very simply, any elements right there in that football were counted in A, were counted in B, so they were double counted, so this takes care of the double counting. So it's going to be just, you need to remember to subtract the football. That's going to correct the double counting. Okay, that one's not too bad. It's this third one that's a little bit harder for students to remember. For three overlapping sets, the number of elements in A or B or C equals the number of elements in the A circle plus the B circle plus the C circle, just adding them up. But then we've got that issue of the double counting, so we subtract the AB football, we subtract the AC football, we subtract the BC football. Hopefully you can see those footballs right here. But then we've got one more problem. The things in the middle there, I call that the bullseye. Those totally disappeared. And let me show you. Anything in the bullseye, it was counted 3 times, A, B, and C. It was subtracted 3 times, the AB football, the AC football, and the BC football. So poof, they disappeared. So what we've got to do is go back and restore them with the ABC football, or I'm sorry, bullseye. So the way that I remember this is we add the circles, we subtract the footballs, and we've got to restore the bullseye. So once again, you add the 3 circles, you subtract the 3 footballs just like you did before, and then you've got to restore the bullseye. So there you have it, how Venn diagrams work with overlapping sets.